Okay. Oh, excuse me, guys. I got the sneezes this morning. It's not COVID. It's just the sneezes. Okay. So anyway, today should be a concept that everybody should know. It's the Pythagorean Theorem. Okay. So we know it only works in a right triangle. So it only works. Has to be a right triangle. That's the first thing. So Pythagorean's theorem only works in a right triangle. If it's not a right triangle, it will not work, okay? So you guys have learned it as a squared plus b squared equals c squared, but I like to rewrite it like this. I like to rewrite it as leg squared plus leg squared equals the hypotenuse squared, because not every triangle is labeled ABC. So for example, in a right triangle, the longest side, they call it C. Okay, great, C. But, let's call it what it is. The longest side is called the hypotenuse. Okay, and then these two other sides of the triangle, only in a right triangle, are called legs. In a right triangle, these are called legs. That's a leg, and that's a leg. I know, kind of weird to call a triangle has legs, but, just think about it having legs. Walk away. But the hypotenuse is always the longest side. The hypotenuse is always opposite the 90, okay? So that way we don't get confused, because I like to call triangles things like PIG, and if the triangle is PIG, then these don't make any sense, right? Because then it would be like that'd be I, and that'd be G, and that would be P, okay? So anyway, I like to call it leg squared plus leg squared equals hypotenuse squared, okay? Now, what do they call a triple? A triple is if it happens to work out perfectly. For example, these are what we call triples. These are numbers that math teachers like to use because they're nice numbers. They're not all messy fraction decimal numbers. So, example. Sorry about that. What is a Pythagorean triple? Let me give you two examples, okay? If I had a right triangle, and this side was 3 and this side is 4. Can we find this side? Sure, Pythagoras Theorem. We're going to go leg squared plus, oops, you can't see that. We're going to go leg squared plus leg squared equals hypotenuse squared. We're going to go 3 squared plus 4 squared equals, we'll say, c squared. Why not? And then that's 9 plus 16 equals c squared. And you get 25 equals c squared. When you take the square root, square root of 25 is 5. And that's a nice number. C is a nice number. It's a nice whole number. However, another example, okay? And all of these work that way, where it's perfect, nice numbers. Here's another example, okay? In this right triangle, let's say this side here is 4. And this side here is 7, and let's find C. All right, well, I would just go, okay, well, I can do this. It's just Pythagoras Theorem. 4 squared plus 7 squared equals C squared. You guys did this in middle school, right? 16 plus 49 equals C squared. 16 plus 49, I get an answer of 65. And if I took the square root of 65, it's not a nice number. Square root of 65, let's see, what is it on my calculator? Square root of 65 is like an 8.06, blah, 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 blah. So it's approximately 8.06, blah, blah, blah. So, see the difference? This is a nice whole number. All three numbers are whole numbers. That's a Pythagorean triple, okay? If it doesn't work out that way, it's just a number, but it's not a Pythagorean triple, okay? So these are the Pythagorean triples, okay? We like those as math teachers, okay? Now, let's take a look at an example where we know C. So for example, here if I know this side is 10 and this side is going to be, let's make it 8, and we want to find this side, okay? So if I said A, B, C, I'd say, well, A squared plus 8 squared equals 10 squared, okay? And then I would solve, and I go, okay, A squared plus 8 squared is 64, 10 squared is 100, I had minus 64, right? To solve, I have a squared equals 36. And if I square root, hey, that's a perfect triple. What do you know? That's a nice number. They don't always work that way. A equals 6, okay? So if the c is the unknown, and if you know c and you want to find the other two, then you choose Pythagoras Theorem and you solve for the other side, okay? Now, finally, this one says that if you do your a squared plus b squared, if a squared plus b squared is less than c squared, then it is not a right triangle. And as an example, let's look at an example of that. Let's say I have a triangle here. And let's say this side is, let's make this 6, and let's make this side 7, and let's make this side here be 10, okay? Is it a right triangle? Yes or no? I don't know. Is 6 squared plus 7 squared, is that equal to 10 squared, okay? Is this a right triangle? I don't know. I didn't put the little right triangle thingy on there on purpose, okay? So let's see. I got a 36 plus a 49 equals 100. Let's see. Okay, 36 plus 49. I get an answer of 85. Well, 85 is not equal to 100, but it's going to be less than 100, okay? So it's less than 100. Then these two sides aren't big enough to make that, okay? So if a squared plus b squared is less than c squared, this one's obtuse. So I drew it wrong. It should be more like this. 6, 7, 10. This is an obtuse triangle. And if it's the other way around, if this happens to be greater than 100, then you have an acute triangle. Okay? And that's about all I have. Today's homework's pretty simple. You're just going to use Pythagoras Theorem to solve. It's pretty simple to do. So that's it. Pythagoras Theorem. You guys already know this. This should be an easy assignment. I want you to do this and get her done. Okay? That's all I have.